Let's solve the problem task scheduler today. And this is the one of the popular problem in a LeetCode. So first try to understand and then we'll see uh, the approach and then we'll write the code. So in a task scheduler, in this problem, we need to find very minimum cycles to accomplish all the tasks. So these are the tasks A and B, and there's a intervals that's a 2, or we can say it's a cooldown period. So uh, just consider A is a process, and once we start the A process and then it just starts working, and then we cannot take A again for these 2 times. So we started A, we cannot take A, we cannot take this A, but we can take any other process if that's available. So we can take B, but again we cannot take another 2 times uh, sequentially, this B again. So we have to wait, wait for this too. So and we need to find out what is the minimum cycles to accomplish this. So that's count we need to find out. So let's see in this example, the interval is 2 here. We started A, so A is getting processed. So this is A job. We cannot take A again, so we took B, and then there's an idle here, 1, 2, and after these 2 times we can take A again. And if from the B, if you count 1 and 2, you can take B again. So B, and then again idle, we can take after A again, after 2, and then B. So if you count this, the total count is 8. So that's why the answer is output is 8 here. So we want very minimum cycles to accomplish this. So in this case, there are this process A and B, the count is exactly same. But in the case of other example, you can do the same way. So in order to solve this problem, we analyzed one thing. This occurrence of this task. So the A is 3 times, B is 3 times. So in this case, first we need to count, the number of the occurrence of the task. If you start from the max occurrence, then we'll take this, and then we can wait for the interval, and we can take another process. In that way, we can accomplish the task in a least amount of cycles. So that's the thing. First, we need to start from the highest task. But in this case, anyway, these are same count. Yeah. So the first thing is, so in order to do that, we need to count this. We can first store this count in a map. So what I do that first, store count of task in map. And once we have the count, like let's say we have the 3, and for this also 3. Second thing, we need to get this item one by one from the structure, some data structure we need to have. And here we'll use the max heap data structure. And in a max heap data structure, we know the highest or the max value come first. So in this case, in a data structure, what I do, uh, I will store 3 in a 3 here like this. I will store 3 in a max heap, and from the max heap, I will take this 3, and I take 3, and in the somewhere I can just add that count to 1. I just take 3 and I just count is 1 now. So first item I took, second item took, and the count is 2. And also, as soon as I get the item from the heap, I also store in some temp variable the the lower number, like in decrement by 1, because if I take 3, that means remaining is 2. If I take this 3, remaining is 2, right here. If you see the number of it, so the 2 again I can store in a heap, but the count is 2. But the next time that should be idle, because I cannot take the a again here till here. So I can just say 3, the count is 3, and then I can put the items on the heap 2 2. From the heap again I will take one by one item, and that will be 4, that 5 and 6, and this becomes 1. And if it is a 1, uh, so in this case it's a 1, and I can also at the end I can put 1 1 here, and from again heap I'll get one by one item, and the count I will increase 7 and then 8. And once I see or temp variable or the heap both are empty, just come out. So that's the simplest strategy I'm going to use. So the one thing is I'm going to use the math here to count this, and the second is the heap data structure, and using the heap data structure I'll use this technique, and then I will get the answer. So in a Golang, in a Java we can use the priority queue for the same purpose. And in a Golang, we can have the heap data structure, and that's like few lines of the code here for creating the data structure. But we can put that in some function or make a small library. I can make use of that. But let's see how we can create this max heap. I have also talked about creating the max heap in other video also. You can check that also. But yeah, let me create one second here. So type, I can just say init heap, and it's a int, and then I need 5 functions here. So let's say func h. We need to import one here, that is container heap. So this package we need to import. So okay, now init heap, we need a function length that's going to return the length of h. Let me copy this. I do not need a star here. I can have a star in this place. Okay, so length, and then another one is less. ij int return, and I greater hi greater than hj. So if I use the less than function here in this less, then in that case that will be min heap. But if I use the greater than, then that will be the max heap. So this way I'm just designing a max heap in a Golang, and this is the way we can just override this high function, and then heap will be ready and we can utilize this. Okay, so this is the less, and the less is returning boolean, so I can make it boolean here, and length, and there is another one is swap. This is not going to return anything, but I can just use hi hj hi. Okay, so this 3 function is ready. Another one is pop, or let's use first push and then pop. So push the item any, Okay, and in this star h, whatever the new item comes, I'm going to append that star h and this item, and that type is int. Okay, in the pop it will return one item, and we'll utilize this function here when we use this heap structure. And this seems like a little bit lengthy here, but this function is very much useful. We have to use in many places wherever you have to use min heap or max heap. So just get used to with this 5 functions here. Okay, so pop the item. I just want to pop from the last, from the end, then star h, last item of this. So that is n minus 1. So that is length of star h minus 1. So the last item we got in an item, and we need to update star h also, because one item is less. So star h should have 0, 2, this one, and we updated that and then just return item. So yeah, so heap is heap is ready here. Max heap is ready. We need to use that. Okay, so we'll use the logic now. So the first one is we need to count this. So we need to use a map data structure. So I'm just going to use m make int. Uh, so that's the character. So I can just say string and then count. I can have int here. Okay, then you have one for loop p range through this task. B is a byte. I can convert in a string and put it here, or can have byte also. Let's have the string for now. So m string p plus equal to 1. So in this way, first it will be 0, and if the same character comes again and again, you can increment that in a map. Okay, so we have this. Now the next thing is we need to put this number uh, in a heap. So let's initialize the heap. So which unit heap, and then we use this is the way to initialize heap dot init h. So h got initialized. Now we need to put this number 3 and 3 here in a heap. So we'll get one by one from this map, and then we'll put there. So in a key, we do not care the key, that is a letter. We just care about this value, 3 and 3 here in this case. So just say key I don't care, and the value range from map, and whatever the value comes, I'll just post to heap dot post h and the v. So h is our heap, and just you can put one by one item there. Okay, so we have successfully put all the items, all this number, and we'll get the highest number one by one, and then we can process. So I'll check for h dot length not equal to 0. As long as there is an item, we'll get one by one item from there. And I want to count this cycle, how many times it takes. So let's use the variable count, and then at the end I will return this count. Okay, so I also need one variable like var temp, and just say int This temp variable I'll use when I get this 3 from the heap. So I process that and then I reduce that by 1 because it's still 3. I process 1, there are 2 items still left, so 2 I want to put it back to heap, so temporarily I will store in a temp and then I'll process again. So for that I use this temp and I'm just checking if I equal to 0 and I less than this n plus 1, because if I start from 0 to n plus 1, then uh, it will go up to this 0 1 2 3 times, so n plus 1 loop. I'm just using this and then I plus plus and then get one item from the heap. So heap dot pop h, so one item come out from the heap, and then that I can just say that's the element. In a Golang I need to convert that to int, so I can say my item here is element and that's int. So that's the item came. Before that I need to, before popping the item, I need to check if heap had some value or not. So if h dot length not equal to 0, then only do these all things. Okay, remove the item. We got the item, and then this item I can also check if this item greater than 1. I can put that in a temp, tmp pend tmp and this item if it is greater than 1, because yeah, if it is greater than 1, then we can process that and then remaining item can put it back to heap. So that's why I use this. So in this way, as soon as I got the item, I'll just increase the count. So that's the count. So that means I got 3. That means 1 processed, count plus plus. Now 2 will back to uh, heap. So that's I'm temporarily storing in a temp, and the later I can put it back. Before that, I'll just check some exit condition here. If this heap length is 0, h dot length equal to 0, and also temp length of temp, if there is nothing there, is that's also 0, then break this loop. So okay, so let's say 3 3, we put the 3 3 and we got the 3 from the heap, and count 1 another 3, count 2, heap is empty but still this loop is running, inner loop is running, and then again count plus plus, it will be one more time, and then we'll have a 2 2 in a temp variable. So now we need to put that back to heap. So this is a still outer loop, h length not equal to 0. Now we'll put that back in a heap. So for range, that's a temp variable, and we'll get item one by one and we'll put it back. So it's a heap dot push h and this fee. Okay, we'll back now, and then this out is this for loop. Okay, this is the for loop, and that's outer for loop, and that's, I think that's all. So let's run this, try to fix any error. Line 7. Please syntax and at the end of source. Okay, here return. We are not returning anything, just swapping the value. Run it again. Hij. Undefined Okay, here. Time limit exceeds. Let's see that count 0. Making count plus first here is length 0 and length temp 0. Then break I less than I plus plus. If there is some item here in this, you can put to the okay. Code looks good. Yeah, still see, there is somewhere in a loop. So it's a length. This is good. We have designed this one code. Hj greater than, that's also hi hi greater than hj. That's also good. The swap. This is the returning the bool and is hi hj hj h. This is good. Hi hj hi. Then push item star h item. Whatever the item gets converted into, and put that back there, and then pop. So in item star h, if I pop the item uh, to length of star h minus 1, that's good. And I can update this star h. Star h has from, since this is a pointer, I need a bracket here, from 0 to length of star h minus 1. So this is perfectly fine. There's no issue here. Now come to this function, and then we have this string aim string plus 1. So that's also good. We initialize the heap.init, and I'm getting item one by one, and heap.push h init h. That's good. Fee. So put the item one by one here. Okay. Now count 0 not equal to 0. This is good. For I equal to 0, I less than n plus 1. That's fine. I plus plus. H length not equal to 0. Not equal to 0. Greater than 0. So if length, anyway, it will come to 0. Does it go to minus 1? I don't think so. Remain heap pop page. That's, we got the item, and then if item greater, you can put that back in a temp, and then count plus plus h length 0 or length of temp go to 0, break. That's also good. Yes, logic seems perfectly good. H and P. So let me try with this. I think, yeah, actually I need, if something greater than 0, then only I want to uh, remove the item. So maybe that's the case. No. So, and at the end we are returning the count. This for loop heap.push. Every item we collected and I put it back. Logic seems good. What is missing here? Where is this loop here? Each length equal to 0 and length of temp equal to 0, then only break. That's also good. There is count plus plus, temp greater than 1. Oh, okay. So yeah, that's the mistake here. Temp greater than 1. So when we append to the temp, this item should be 1 minus item minus 1. Item minus 1, yeah. So that's the, because you got the 3, next time you just want to put back 1. Yeah, submit. This is good. And we can see also Java solution for this. Java solutions, I had already added this code, but let me check. Try blast submitted code. Yeah, this is the one. Yeah, so for the heap, instead of heap data structure, that's a heap data structure, but here in a Java, we use a priority queue. And if you want to make max heap, just change the reverse order here. If you get rid of this, that will be min heap. And we have used the map and then use the same thing, same logic. And again, using the same logic here, getting the item one by one from there. We have the temp variable. Instead of count, I have made a cycle here. And you can find exactly same logic. And at the end, we can return this time here. Okay, cycle is just n plus 1. So time count, yeah, count replaced by time. Okay, anyway, so the logic is exactly same. That's all. Thank you.